In this video, we're going to talk about the difference between diagrams that are labeled as being drawn to scale versus those that are labeled as being drawn not to scale. So there's a couple different ways you can think of scale in geometry. One has to do with real-world objects and how they're modeled or drawn out. That's something we're going to talk about later. In this video, we're going to focus on looking at diagrams of line segments and seeing how well the drawn out or modeled lengths of those line segments match their given values. So when there's a match between the given values and the drawn out or modeled length, that means things are to scale. When that match isn't there, that means things are not to scale. So in our diagram here, we have two separate diagrams actually, but both diagrams have the exact same drawn out line segments, but they are matched to different values. Let's start by looking at the left side diagram first, and let's look at that first line segment there. So it's supposed to be representing a given value of 8. Let's count how many studs are there. We have 1, 2, 3, 4, 5, 6, 7, 8 studs. So that's a perfect match. And then the same is true for all other 3 line segments on this diagram. So 10 studs matches 10 length, 10 studs again matches 10 length, 12 studs matches 12 given length. So these are to scale because we have those perfect matches. Versus if we look at the right side, there's no match or pattern of matches going on. So the first one is given a value of 11, and we have 8 studs, and then the next two are both 10 studs, but one has a value of 21, one has a value of 23. And then when we go to 12 studs, we're jumping all the way up to a value of 50, so more than double, but the length is definitely not double. So these are not to scale. And it's not necessarily a bad thing if things are not to scale. Most of the time, things aren't going to be to scale because you're going to be doing rough drawings of diagrams, and a lot of times things in your text aren't going to be labeled as to scale. But just know when things aren't to scale, you can't really make judgments on the lengths of line segments based on how they look. You have to go with given data or calculations. And when things are to scale, it doesn't necessarily need to be a perfect match between things. Like right now we have 1 stud count. It's kind of like as one counting point is the way I think about it. But we could multiply everything by 2 and still keep everything to scale. So if we multiplied 8 by 2, we'd have 16, 10 by 2, 20, 10 by 2 again, 20, and then 12 by 2 is going to give us 24. So when we do this, it's like each stud has a counting value of 2 instead of 1, but that counting value stays the same between all the line segments, so things are still to scale. And then we could also, multiply by a fraction, which is the same thing as dividing by a whole number. So say we divided by 2 on all of these. So 8 divided by 2 is going to give us 4. 10 divided by 2 is going to give us 5. 10 divided by 2 again is going to give us 5. And 12 divided by 2 is going to give us 6. So now each stud kind of has a counting value of a half. So if we look at the first one there, it's going to be 1/2 or 0.5, however you prefer to say it. And then 1, and then 1.5, 2, 2.5, 3, 3.5, 4. So yeah, you can multiply or divide by any value, but as long as you're doing that to every single part of the diagram, then things are going to stay to scale. But yeah, big takeaway here is when things aren't to scale, you can't really rely on the drawings and knowing how things relate to each other, versus when things are to scale, you can rely more on what your drawings are showing you. In the next video, we're going to introduce the concepts of postulates, theorems, and proofs.